There we go. All right. Angles of a triangle. Now, the nice thing about today is you all know where we're going with this. You all know what the sum of the angles is in a triangle, right? 360 degrees. Good? No? No. What do you mean no?
It's 180.
180. Can you prove that?
No.
Okay then.
Yes.
Yes? You think so?
Isn't that like the Pythagorean theorem?
No. Pythagorean theorem has to do with a squared plus b squared equals c squared. You know, the whole, got to write triangle, you know. We're going to use this picture. Okay, so I took a triangle, happens to be yellow, and I labeled the three angles 1, 2, and 3. Pretty clever that way. Then I drew a line through one of the vertices, the green line, parallel to the other side of the triangle. Okay, so before we get into this proof, quick history lesson. So Euclid is the guy that created geometry back in 300 BC. He was named after the street. Good, at least some people are awake. So when he created geometry, he had hundreds upon hundreds of theorems. He just kept cranking out theorems about geometry. He also had some postulates, and I don't know if we've talked about postulates yet, have we?
No.
Okay, so postulate, we've talked about definitions, we've talked about theorems. Postulates are things that we're not going to prove. You just take to be true. I'm going to tell you what the postulate is. You're just going to trust me, and we're going to move forward. Okay? We have a lot of postulates. And the reason we have a lot of postulates is because some of the stuff that we do is too difficult to prove, or you don't have enough information to prove it, that kind of stuff. Euclid, when he was done with geometry, had only 4 postulates. This is one of them. He said that if I take a point, and we're going to consider that vertex a point, not just a vertex of a triangle, and a line, there's got to be some line through that point parallel to the starting line. It makes obvious sense. Okay, I've got a line sitting there, I've got a point. I can draw a line through that point parallel to the original line. He just couldn't prove it. He couldn't figure out a clever way to show that that's got to always happen. We're going to use the same thing. So I'm magically creating this green line that's parallel to the bottom of the triangle through the vertex 1. Okay? And way back when you did geometry 3rd grade?
Yeah.
3rd grade? 4th grade? 3rd grade?
3rd grade.
3rd grade? We would do a similar proof, but you would take your safety scissors and some construction paper. You know, you get to pick your color out of the pack, whatever is best for your self-esteem. And then you would cut a triangle out of the construction paper, and and then everybody would show their triangle. Oh, look at Alex's triangle. Oh, look at this triangle. Mine's red. Mine's blue. I like yellow. Then you would cut all the corners off. Some people would cry because you ruined your triangle. And then you would lay all the angles out, and sure enough, they would make this pretty nice little straight line. We're going to take the high school approach to that. What's our ultimate goal here? What are we trying to prove in that picture? Eileen?
That the sum of the angles in any triangle equals 180.
Well, good, you can read. But for this particular picture, what am I trying to prove?
That angles 1, 2, and 3 equal 180.
Good. 1 plus 2 plus 3 equals 180. It's a pretty easy proof once you see the setup. And after I ask you a couple questions. What's the relationship between angles 2 and 4? Which means? They're equal to each other. Okay? So let's write some of this down. We are trying to prove, okay, so down here at the bottom, P for prove. We want to prove that angle 1 plus angle 2 plus angle 3 equals 180. And if I can prove that, then we're good to go and we can use this theorem for the rest of the year, for the rest of your lives. Notice I made no stipulations on the triangle. I didn't say it's obtuse, it's acute, it's equal, nothing. It's just some generic triangle with 3 generic angles. All right, so Tom, you said angle 4 is equal to angle 2. Why, did you say? What kind of angles are they? Yeah, they're alternate interior angles. Okay, so a little bit tick markage here. Angle 2 and angle 4 are congruent. All right, what else do you notice in the picture? Matt?
Put 5 and 3 to alternate interior as well.
Which means that they are
Equal.
equal. angle 3 is equal to angle 5, also because of alternate interior angles. And that's why we needed the... Pregunta?
Oh, no.
Just waving your hands in the air like you just don't
I
care?
was gonna say like another thing that like we know from the picture.
Oh, go.
So 4 plus 1 plus 5 equals 180
Okay, why?
because it's supplementary angles.
Hold on, my pen's getting all wonky here. So as you can clearly see, are you done? No, you're not.
Try to allow wait for it.
Oh. Oh.
Okay, so as Grace said, clearly we see angle 4 plus angle 1 plus angle 5 equals 180. And why did you say that's true?
Because they're supplementary.
Oh! Somebody help me out here.
They're not supplementary because supplementary angles it's only 2 angles, so they're. Oh, okay.
Is she right, first of all?
Yeah.
Yeah. So why? Why? How would you explain? So you're sitting at the dinner table with you have a little brother, little sister, got a dog. Got it. Okay, so you're sitting at the dinner table, you're trying to explain to your dog why angle 4 plus angle 1 plus angle 5 equals 180. What would you say to the dog?
Because if there's a straight line, it has to equal 180 the angle.
Great. And the dog just looks at you like you're weird and walks away. Okay. So now what? I've got angle 4 plus angle 1 plus angle 5 equals 180. I got angle 4 equals angle 2. I got angle 3 equals angle 5. How do I get to this? Natalie.
So because angle 4 plus angle 1 plus angle 5 equals 180 degrees, and angle 4 is equal to angle 2 and angle 5 is equal to angle 3, they're the same thing, so angle 2 plus angle 3 plus angle 1 equals 180.
I'm going to get rid of this. Oh, now it's working. I'm going to get rid of this angle 4 because those things are equal, and I'm going to put in 2. So this becomes angle 2. I'm going to get rid of this angle 5 and put in angle 3. I'm going to leave the angle 1 there, and I'll leave the 180 there. Do you know what that's called when you get rid of something and put something else in for it? Substitution. Yeah, substitution property. That's it. We're done. So we just proved what we're trying to prove.
Does it have to be in that order?
It can be in whatever order you want. Because 1 plus 2 plus 3 is equal to 2 plus 3 plus 1 is equal to 3 plus 2 plus 1 is equal to 3 plus 6 possibilities. I'll stop there. It doesn't matter what order it's in. What makes that a proof? So this is a big argument that geometry people have all the time. What constitutes a proof? Did I prove that for every possible triangle? The answer is yes, because I didn't start with a specific type of triangle. I didn't make a statement about the triangle. I just said, I have a triangle. And that triangle has 3 angles, because it's a triangle. And then I put that parallel line through there. If I was to start the proof by saying, oh, I've got this isosceles triangle, that's a different scenario, because then I will have proven it only for isosceles triangles. This is triangles in general. Okay, so we're good to go. From now on, we can use that, and we can just sum up the angles in a triangle till our heart's content. Any problems? Solid? Okay, good. If we change that a little bit, by taking one side of that triangle and extending it, I get something that's called an exterior angle. Angle 4 is an exterior angle. So the question first is, what's an exterior angle? Christian, how would you define angle 4?
Um,
What makes that an exterior angle? And don't tell me it's exterior.
it's outside of the triangle.
Is that it?
I guess.
That's outside the triangle. Is that an exterior angle?
No.
No. Okay. So what makes that angle 4 an exterior angle? You raising your hand? 'Cause initially you just had your pinky in the air. Is that like the courteous way to raise your hand? Please call on me, sir. I might have an answer.
Is it an angle that's supplementary to one of the angles of the triangle that's on the outside of it?
Hold on, let me run that by the masses. Did you hear her?
No.
Say it louder.
An angle next to, adjacent to the triangle that's supplementary to one of the other angles inside the triangle.
I don't know. What do you think?
Sure.
An angle that's adjacent to an angle and supplementary to an interior angle of the triangle. Okay, so I'll draw another exterior angle for this triangle, and you can tell me, I don't know, am I still writing here? Yes, okay. That's also an exterior angle. Does that satisfy her definition?
No.
It doesn't?
It does.
Is that adjacent to an inside angle?
Yes.
Is it supplementary to an inside angle?
Yeah.
Yeah. If her definition is good, how many exterior angles would this triangle have? I got 3, I got 4, I got 6. 6, 6, 4, 3, 2, none, 0, 1, 9, 4, 9, 12,
6.
6, 6, 6, 3, 3, 3, 9,
11.
6, not 3, 9, I can't sell you on 9. 3 vertices, 3 vertices, 3 exterior angles,
Yeah, 9.
8. We won't take 9, we take 8. Okay, so what if I do this? Oh!
It's vertical, not adjacent.
Oh, nice. That one doesn't count. So you're right, it is 6. Okay, one last thing, Alyssa. If we're going to use that as a definition, we want it in if-then form. Now the hard part. Take your definition, which was rock solid, and write it in if-then form. Or if you prefer, you could write it in that form. You know, like cow implies moo.
If an angle is adjacent to an interior angle of the triangle and is supplementary, then it is an exterior angle.
Good, but let's clean it up a little bit. Can you be supplementary? Oh, I guess you can. Yeah, I like it. Say it again.
If an angle is adjacent and supplementary to an interior angle of the triangle, then it is an exterior angle.
Okay, one last thing and then I'll leave you alone. When we talked about reversible statements, we said all our definitions have to be reversible statements, meaning it has to work both ways. So the conditional and its converse have to be both true. So the converse of your statement would be, if an angle is an exterior angle, then it is adjacent and supplementary to an interior angle of a triangle. Does that work? Did she write a solid definition? Good job. Okay, let's give it up for that one. That was one more time.
Converse or?
The original one that you get.
If an angle is adjacent and supplementary to the interior angle of the triangle, then it is an exterior angle.
Excellent. Okay, so now we got a definition of an exterior angle of a triangle. We're going to focus on one of the 6, in this particular case 4. How does the measure of angle 4 compare to some or all of the other 3 labeled angles?
Angle 4 is equal to angle 1 plus angle 2.
In case you didn't hear, she said angle 4 is equal to angles 1 plus 2. How do we feel about that? Grace, you're saying no? Why?
Because it would be only equal to 2. Only equal to 2.
So you're saying angle 4 is equal to angle 2?
Yeah.
Okay. Anybody else?
Angle 4 is obtuse.
Angle 4 is obtuse. You just want to just throw that out there? Great. Yeah. I'm afraid of clowns. Okay. Why is your statement relevant?
Because angle 2 looks acute.
It does appear acute.
So then it wouldn't be equal if it is true that angle 2 is acute.
Okay. Let's. Oh, yes.
Well, all 3 angles of a triangle, as we proved, equal 180, and that's only 2 angles of a triangle. If it's just equal to angle 2.
Let's do some algebra, shall we? So you're saying. Yeah, that sucked. Angle 1 plus angle 2 plus angle 3 equals 180. Okay? What else do we know? Based on your definition, what else do we know?
Angle 3 plus angle 4 equals 180.
Using the substitution property that we did before, we're going to get rid of this 180 and put in this mess, because they're both equal to 180. So angle 1 plus angle 2 plus angle 3 is equal to angle 3 plus angle 4.
Take out the 2.
Whoopsh, whoopsh. Angle 1 plus angle 2 is equal to angle 4. Well, whoops. Well done. Okay. So an exterior angle is equal to the sum of the other interior angles. And there's a couple different ways. I don't remember how I phrased it in my slideshow, but we can just put a dot there too. There we go. Okay. The sum of the 2 remote interior angles is the way I phrased it this time. Okay, remote meaning away from it. Because it's obviously supplementary to the one next to it, because that's how Alyssa defined it. So therefore it's equal to the other 2 angles in the triangle. And if you forget that, it's not the end of the world, because you can go through the same thing we just talked about. Angle 1 plus angle 2 plus angle 3 equals 180. 3 plus 4 equals 180. Do some algebra, you get your answer. But remember, it's got to be supplementary and adjacent to those interior angles. We're going to exclude the vertical angles that Jalen mentioned before. So only 6 of those possible angles. We good? Corollaries. I know we've talked about the word corollary, right? Come on, really? Corollary is like a sub-theorem. It's another theorem, but it's not important enough to get its own theorem, so it belongs under the other ones. Number 1 we did already. We did that on Friday when we talked about the right triangle and talked about the 2 acute angles in a right triangle. They have to be complementary. Complementary meaning what? They add up to 90 degrees. I believe we also talked about number 2. Why can there not be more than one right angle in a triangle?
Because 3 angles have to add up to 180 and 2 is already.
You got 2 90s, that's already 180. You got another angle of 0, no triangle. Same thing is true with obtuse. 120 plus 120 is 240 over 180, doesn't work. And so you see why those are corollaries, because they're not important enough to have their own theorems. They actually are sub-theorems of the things we've already talked about. Okay, solve for x. You on the first Tuesday of the month. Franny, is that too much sun? You're good? All right, excellent.
Maybe there's going to be an actual tornado during the time of testing the siren. No one's going to see it coming.
That's not a tornado siren, that's an air raid siren. It's in case the Ruskies attack.
All jokes aside, it's probably going to happen soon.
Yeah.
Putin wants Ukraine.
That's one America.
Yeah, but America has already interfered in everything. I think there's war in the Middle East right now. Because we don't like Russia. It's soothing, you know? It's my sleep.
Once you get an answer, check with your neighbor to see if he or she has the same answer. If not, figure out who's wrong.
Yes.
Really?
How about 83? Yes?
Trash is actually good. Because 180 minus 11 equals 9. This hand through.
That's kind of trippy. Look what it did to the triangle there.
And there's two other sets.
Like Inception. Put a triangle inside a triangle. It's going to stay that way now. Great. So as you can clearly see from the example, x plus 72 equals 2x minus 11 because the exterior angle is equal to the two remote angles. And then when you do the algebra, you get 83. Now the dot shows up. Okay, strangely enough, we're done. Most of the homework tonight involves calculating angle measures. Be careful because there is a trickle-down effect. So for instance, if you have a big complicated problem and you're asked to find an angle early on, that the value of that angle continues through the problem. If you screw up with the angle at the beginning, that mistake is going to carry throughout the entire problem. So don't be bashful about busting out that calculator and making sure your numbers are in fact correct.
That's actually a good one. You need it?
Yeah, I read it.
See you.